Good morning, everyone. Welcome. We're glad to have you with us this morning. If you'd like to write in the chat and say hi and tell us where you're connecting from, that would be lovely. As we give people time to join the webinar. So welcome everyone to Enhancing Research Data Management with EUDAT and FAIRCORE4EOSC. My name's Zach Smith. I'm from Trust IT and I'm part of the FAIRCORE4EOSC project, but I also am part of the communications team for EUDAT. So I find myself in a perfect position to present both EUDAT CDI and FAIRCORE4EOSC to you in this webinar, and I'm very excited that we've got some great speakers with us to talk about how the FAIRCORE4EOSC project and EUDAT is interacting and working to make research data management services even better. So just some housekeeping announcements. The slides and webinar recording will be available sometime next week. So don't worry about, if you miss something on a slide or needing to screenshot things, we will make them available. Please ask your questions in the Zoom Q&A tool. If you're not familiar with Zoom webinars, we have the Q&A tool, which is next to the chat. So I'm just looking in the chat now. Nice to see some people. Got Netherlands, Finland, France, Hungary, Germany, Spain, Austria. So it's nice to see people join from a lot of different countries. I'm joining from Italy. And so please use the Q&A tool for any questions. We will have a time at the end to speak to the whole panel together of all the speakers. And so any relevant questions will be asked then. Maybe some of the panelists will respond to your questions directly in the Q&A if you have them. And the last thing I'd like to say is to make sure to follow both FAIRCORE4EOSC and EUDAT on LinkedIn and X for regular updates, or X Twitter, whatever we call it these days. And as you can see, here's the agenda, and we're in the first part. Next, I'll hand over to Mark to talk about EUDAT. Then Tommi will talk about FAIRCORE4EOSC. And then Heinrich will talk about the specific service that is being enhanced by FAIRCORE4EOSC. And then Harry will talk about another one. And then we'll get to the time of Q&A and the panel session. So I'll hand over the floor to Mark now. Please turn on your camera and share your screen, Mark. And
okay, I will do. Okay, I get from Zoom. You can't start your video because the host has stopped it. So I think you need to enable my camera. Video. Okay. Then I will start sharing my screen. And hopefully you can see my slides.
Yep, we can see them.
Okay. Good morning, everyone. I'm Mark van der Zanden. I'm from SURF, and I'm also the technical coordinator within EUDAT. And in these slides, I will provide a short overview of EUDAT as the organization, a little bit of the services which we are providing, And also I will address some use cases where you can see, okay, how the services are being used by, for example, communities. EUDAT, CDI, EUDAT Collaborative Data Infrastructure is one of the major infrastructures in Europe. And we have a vision as that we want to have data shared and preserved across borders and disciplines. And if you look at this vision, it is very similar as, for example, how EOSC also has this vision as to be able to share data across borders and disciplines. And to be able to achieve this, EUDAT is also providing a set of services, but also a set of components which can be used to build up your services. And we are trying to aim that researchers can use services and to support them throughout the research data lifecycle, so that they are able to manage the data in a better way. EUDAT is a member organization. At the moment, 24 organizations are a member of EUDAT, and they are spread across 14 different countries. And as you can see, there are the spread is really across many countries within Europe. In many of the discussions, we are looking at data, but also at different stages and different levels of data. And we very frequently use this diagram to explain the different levels of data. As you can see, we distinguish which is more in private data domain, where still a lot of data is made available. Users are very active in producing and analyzing and working on the data. So the data objects are also very actively changing, frequently updates. And then we're also looking more at the shared data domain, where the data is becoming already more stable, is also already more described, but also is shared within different teams, which can be within your own domain, but also already in different collaborations which you are working with to, for example, to produce any publications. And then we are more going to the top, and then we have the published data domain, where the data is stable, it is well described, but also is preserved over long term to make available, so that you really have links to the different kind of publications. And if you look at EUDAT, EUDAT is more looking towards the shared data domain and providing components so that users are able to easily share the describe, but also make data discoverable within their own domain, but also within the collaborators. And for this, we have been developing a different set of services and components which can be used by the research, but also communities to build up their infrastructure. And if you look at this, this is our suite of components which we have been developing. And if you go to the top, there we have B2Find, which is a data discovery service. So we harvest metadata from many different repositories and make this discoverable to users to find interesting data sets where they can work with. Going to one step below this, and we have the data access and sharing layer, where we have different kinds of services as B2Share, which is a data repository service, but also technology, via which you can easily set up a data repository and make and describe your data and make your data shareable within your domain. And if you then go to the right, we have B2Drop, which is a service which can easily be used for active data, sharing of active data. It is a sync and share type of service, so you can collaborate with your fellow researchers to share the data, but also integrate this with different kinds of platforms where you can share the data across different kinds of services. On the data management layer, we are looking at B2Safe, which is a service in which you can implement different kinds of data management policies. You can integrate this with different kinds of data services, but also integrate this with different kinds of storage type of platforms. So you can create a virtual environment for making the data available, while you're also implementing data management policies to improve your data practices in general way. We also use therefore, for example, the beta handle server to assign persistent identifiers. So at an early stage, you can already use persistent identifiers to link this to data objects, but also to data sets. Therefore, you see that beta handle is integrated with different kinds of services, as with beta safe, so that you want to have, for example, PIDs for data objects, we can automate this process within the beta safe, but also, for example, if you have a publication in beta share, then you can also assign PIDs to the data sets, but also to the data objects. And at the lower layer, we have the beta access service, which is our infrastructure proxy to provide access to the different services within EUDAT. So therefore, it is integrated with the different services to do user access management of those services. In this slide, we provide some numbers of how the services are being used, but also how many communities we have within our domain making use of the services. For example, within B2Share, we already support for 24 different communities, which make the data available, but also we support them by having different kind of metadata schemas supporting the communities. Within beta handle, we provide a large number of prefixes across different kinds of repositories, but also, for example, we have already registered more than 30 million PIDs, assigning to data objects which are stored by the communities. Within beta find, we make more than 1 million data objects discoverable from more than 100 repositories, which are hosted by not only EUDAT members, but by different communities which we collaborate to make the data discoverable. Going to the other services, I will not go through all the details of the numbers. But for example, within B2Drop, there we have also, as you can see, for example, we offer the services also as a premium level service, which EUDAT can offer those services towards users in a pay-as-you-use format. And we already do this for a number of communities. To support the researchers and research communities in the research data lifecycle, we have been looking to see, okay, how does our services fit within the lifecycle? And for this, we have developed this diagram. There you can see actually that there are two different life cycles. One more from a community perspective, where the community will manage the data, but also the generation of the data, but also the production of data sets and data products for their researchers. And then you have more a data lifecycle for the individual researchers who want to work with the data to produce and analyze the data, but also then again, for example, produce publications around the data they have been analyzing. There you can see that how our services are fitting in the different life cycles from community perspective, but also from how we want to support individual users. Where, for example, if the data is being generated, it can be managed via policies in B2Safe, it can be published within B2Share. PDs are then to be assigned for identifying the different data objects, but also when the data is being published, it is made discoverable by B2Find, where the individual researcher can find the data, can select the data, get the data, store them where they need to do this at the processing level, or within data platforms as, for example, B2Drop, where they collaborate with communities and with other researchers to produce publications and outputs. And then again, when they have the output, they can preserve for a long time according to B2Safe policies and make the data again published in B2Share. And if you look at this, this is one of the use cases which we have been working with one of the communities, which is the CombioMed community, to see how this works within their infrastructure, how they can set up an infrastructure where they want to support their users. Within the CombioMed use case, they are really looking at to see, okay, how can they link the system, the machine where the data is being generated, how can I offer this towards the users so that they also can make use of the data, analyze the data, and also publish data sets on basis of the analysis they have done. And this is a distributed use case where you can see that the Signatron is hosted in France by ESRF. There's the data being generated. The data is transferred to Barcelona supercomputing, where the data is first processed, data products are being generated, are stored in BetaSafe, PDs are being assigned to the data objects, then distributed across different sites according to different policies, to different organizations, as for example the supercomputer at SURF, but also the supercomputer at DKRZ. This is all done through data management policies as implemented within BetaSafe. The users get access to the data, are analyzing the data, but also when they are analyzing the data, producing new output, which they also publish in B2Share. When the data is being published in B2Share, which is an instance hosted at UCL, then also the data is being made discoverable B2Find. As you can see, what we want to try to do within EUDAT is to provide different kinds of components so that you can set up a whole full infrastructure to manage your data, to also provide those kinds of components towards the users so that they can manage the data through the full research data lifecycle, including also linking to processing and making the data discoverable. This is a very short introduction to EUDAT. If you have any questions, not sure if they're already in the chat or in the Q&A. Also, we can always address this at the end of the webinar.
Thank you so much, Mark. So I'd like to ask Tommi now to present, who is the coordinator of FAIRCORE4EOSC.
Right. Does it show as it should? Hope so.
Yep.
So, FAIRCORE4EOSC. We'll try to summarize this in about 10 minutes. It's called FAIRCORE4EOSC, so I have to a little bit say about EOSC. The concept of EOSC as such is under flux a bit, with a procurement and a little bit of a redefinition of the concept. But we have been now going on for a year and a half. And our starting point was to the Strategic Research and Innovation Agenda called SRIA, that was created in 2021, that identified gaps in the state of the art and highlighted the Web of Fair data and a minimum viable EOSC by 27 as the main targets. So a lot of these gaps were focusing on trying to well, essentially identify things that need to be done to reach the MVE EOSC by 27, and that is new core components or services that are still missing from the portfolio in order for the EOSC to operate. And that was the starting point. We are now in month 19 of a 3-year project, so just past the halfway marker. We have 22 partners, about 10 million euros, and we're coordinated at CSC, but Mark, who was just talking now, is our technical coordinator. So we focus on developing 9 new EOSC core components that are specifically tailored at addressing the gaps that were identified. Thematically, from those gaps, this particular call addresses these 4 topics. So persistent identifiers, metadata and ontologies, interoperability, and research software. So the 9 core components that we work on developing are first, the RD graph, so the research discovery graph. This is essentially an open air extension of what they're currently doing. They have this graph of interconnected research objects, not necessarily identified by persistent identifiers, and they started out with very messy data sets. So they have had to do a lot of cleaning of the data, deduplication, and a lot of work to work with what they have. But it is a very large graph of related research objects. Now, this is software, publications, data sets, everything possible. They are working on creating subgraphs, for example, for specific communities or countries, whatever the delimiting criteria is. They're looking at natural language search into graph data so that you could express the query. I would like to see publications of the 10 most cited researchers in the field of I don't know, boreal forests. So that should be able to translate it into a graph query that to then return results about the research objects that match the query. They are working on quite a few different sub-technologies to enrich this graph. And the idea is that this would be integrated in EOSC so that to allow discovery within EOSC of interesting research objects. Then we have the PID graph from DataCite, which has a bit of a different starting point. Here, all the objects are inherently PIDed, and it is always PID to PID connections that we are discussing in the PID graph. It is likewise also a knowledge graph in a similar manner, but then it is working on providing an API for accessing the graph to perform graph queries into it. It is providing a data dump of their data, as is the RD graph. Then they're looking at this kind of usage statistics. For example, that how many times has this data set been accessed, so opened, downloaded, cited, so different kind of metrics related to the utilization of the objects of the graph. And here the quality of the data is slightly higher than with the RD graph, but then I think the comprehensiveness is a bit less because they don't try to deduplicate on all the non-PIDed data. And then we are building something called the metadata schema and crosswalk registry. So this is a service where you could or you can deposit metadata schemas of your services, such as of the EUDAT beta store. Then the idea is that you can also deposit schemas of other services. And then once you have the schemas of two different services, you can create a crosswalk where you map the individual metadata schema of one schema to the metadata schema of another one. And utilizing that mapping, we call it a crosswalk, which you can store in the service. You can publish it, you can get a PID for it, you can version it, you can it becomes a linked data object that everyone can see with provenance information. Then that can be operationalized. So that means that you can use the operationalized crosswalk to actually calculate the conversions from metadata to metadata of one service. So that allows services to exchange metadata between each other. For each of the domains, we try to identify a so-called core standard or a core schema. So we essentially try to map all the services to a core schema that is seen to be expressive enough. So then all the services essentially need to map to and from the core schema, and that will allow all services that are mapped to the core schema to exchange information within that domain with each other. Then a service that also supports very much the metadata schema crosswalk registry is the data type registry. So this is a place where you can, for data sets or metadata sets, define the data set, types that the attributes of a data set or a metadata set may contain. This can also be used in PID kernel information profile definition, but it gives you a PID and the precise definitions, labels in many languages of the data sets so that you can refer to them in a linked data manner. We can also then utilize this information in the metadata schema and crosswalk registry to say that this particular string looking field is in fact coordinates. And the coordinate has a specific format, and that allows you then to understand and process the information much better. Then we are working on developing the PID meta resolver. So first of all, for those PID types that will be incorporated, you simply don't have to care where to resolve the PID. You just give the PID to the system and it will resolve it to whether it's a handle or a DOI or a URN. It will has the capacity to resolve you directly to the source. But at least as valuable as that is the possibility to actually not resolve, but to get the metadata of that object. So this is a system by which you can get metadata on all PIDed objects of those PID systems that are registered, and that allows you to populate your system with information of what is behind that PID. And that's where the kernel information profiles become relevant. So we are looking at the possibilities of improving or making the PID kernel information profiles of different PID systems a bit more compatible with each other, so that it would enable getting more metadata on the PIDed object, which then allows you to populate your system with information about the object the PID is pointing to without actually resolving to it. Because in the case of journal publications, it will point to a web page with a PDF, which is not very good for machine actionability. Then we are working on the EOSC PID policy compliance assessment toolkit. So EOSC has developed a so-called PID policy on the recommended utilization and good practices of using PIDs. And the idea of this tool is to be able to evaluate services with regard to their EOSC PID policy compliance. Then we are introducing to Europe a new identifier system that has been developed by the ARDC, so the Australian Research Data Commons, and that is the RAID, so the Research Activity Identifier Service. That's essentially an identifier for research projects. So besides being the actual PID, which has now been chosen to be a DOI, it additionally has a very rich metadata envelope that points to project-related participants, services, data sets, publications, people working on the projects, grant agreements that have funded the project. So these are longer-term activities, which then kind of, it works as a capsule for information related to that activity. And also, by the way, a prime source of information for the graphs. Then we look at two software heritage related initiatives. Software heritage is an entity affiliated with UNESCO that sees source code as a part of humanity's cultural heritage. And it tries to essentially archive all the source code in the world. It harvests many different repositories of source code, and we focus now on improving its coverage of research software. So we developed connectors and APIs to connect to a lot of research source code repositories so that it may harvest their metadata and assign also software heritage intrinsic identifiers, so SWIDs, to them. Yeah, so this kind of also then gives the possibility to cite source code using the SWIDs. Additionally, the whole archive of source code of the world, we create a mirror for it in Greece to actually mitigate the risk of information loss and losing out on this or possible like service breaks. So that is a parallel effort then. And these are the 9 core components that we develop in the project. What am I doing with time? I think I should finish now. So then I will go through quickly just mention that we have 5 case studies. Clarin, which is the linguistic resources, DKRZ for the climate change, FIDS Karlsruhe for mathematics. Then we have CSC doing the integration of national research information systems. And then we have finally an EUDAT focused case study, which will be probably addressed in more detail by the following presenters. So these are ones, you can see there which of the different components we're developing these communities are planning to adopt. And the idea is that the adoption of these services would actually result in long-lasting benefits for these communities that these are worthwhile adopting, not just to show that these services are good and valuable, but also for their own sake. Finally, we're about halfway through the project. We have just released the beta versions of our components. In 4 months' time, they will have been initially tested with the case studies, and we will launch an updated version of the components with further development. And then we have still 1 year to by next year, by 2025 March, to release the final versions of these components, which should be then having the full functionalities. And with that, I have overstepped my time. I apologize. I'm done.
Thank you very much, Tommi. Don't worry, it was a very nice presentation, and you explained very clearly the different components, even though they're very technical. All right, so now we get to hear about some of the interaction between EUDAT and FAIRCORE4EOSC. So I'll pass over the floor to Heinrich, and you can now share your screen.
Yes, I hope so.
While Heinrich's sharing your screen, I'll just mention we will answer the questions at the end of all the presentations. So we're not ignoring them, but we'll get to them.
Okay.
You need
Hello,
to put
you
it in
can...
presenter mode. Sorry, Heinrich. I can see the...
okay. So I just stop sharing and go ahead to the screen with presentation mode. Looks better now?
Yes, perfect.
Thanks. Okay, hello everybody. My name is Heinrich Widmann from the German Climate Computing Center in Hamburg. And I want to talk about the B2Find enhancements, so coming with integration and utilizing some of the FAIRCORE4EOSC components Tommi just presented. And I thank here to the B2Find team, especially to Anna-Lena and my colleagues Anna-Lena and Anne, who as well contributed to the slides. Okay. Okay, B2Find. So what is it? Or I explained it with the ingestion workflow here of B2Find. So it's 3 major steps. So first, B2Find harvests from a lot of repositories and data sources, not only from EUDAT data centers, but as well from a wide field on interdisciplinary and cross-domain communities. And we use here several protocols for harvesting. Preferably, we use the OAI protocol for metadata harvesting, but as well, B2Find supports other protocols like JSON APIs, or CSV stands for Catalog Service for Web, to harvest from geo-networks. Since long, we have on our agenda that we want to as well to collect metadata via SparkQL, so to collect triples for linked open data. So, but we had no resources for this to implement this, but we will hopefully now do something here in the context with the PIT graph. And then the next big step is to map all this harvested metadata from the specific community metadata schemes onto the common EUDAT core metadata schema we use here in B2Find, and by the way as well used by B2Share. It's a lot of work. It's of a technical converting, and you need intense communication and negotiations with the new uptaken communities too, because they have all different demands and requirements. And so we support, as listed here at the bottom, a lot of standardized schemas. And most of them are as well have specific community-specific fields or flavors. And as I show later here, we want to use the MSCR to improve here or simplify our operational mapping workflow. And finally, the mapped and homogenized metadata records are uploaded and indexed in the B2Find's discovery portal. And so this allows then facet search over the wide field on data sources coming from different research domains. So, and we have here a lot of facets and option filter options. So, for example, we have here the possibility to select by spatial and temporal coverage via world map, etc. pp. And as well, we have, for example, here the facet research discipline. So because B2Find as whole EUDAT follows a real cross-domain interdisciplinary approach, and then you can filter by domain. Okay, and it's important as well in whole EUDAT is the concept that we use persistent identifiers to identify a referencing clearly to the objects and the whole the metadata or metadata entries in the records. And here as well, the pit graph will come in the game. So I go forward to the next slide. So here's a summary how B2Find demonstrates some of the components Tommi presented. So on the left-hand side, you can see that we use the graph components, the research discovery graph and the pit graph. So essentially, we integrated the B2Find metadata in the research discovery graph. So I show later how this worked out. And then in the next step, so we not really started with this, but then vice versa, we want to use the graph information from the pit graph to enhance B2Find records by external references and links and to improve the interlinking. Okay, and on the other hand, so on the right-hand side, we as well, so as Tommi already explained a little bit, we want to use the metadata schema and crosswalk registry to support and simplify our operational ingestion and mapping workflow here of B2Find. So this, I show this later a little bit more in detail. So by uploading not only the community metadata schemas as source, but as well the target metadata schema, what is here the EUDAT core metadata schema, and as well upload first the first initial crosswalks and then use the metadata schema and crosswalk registry then to use the updated and changed and the versioning, so for operational workflow. Okay, good. I illustrate this all with some slides which follow. So in B2Find, as said, so we harvest from now about 100 data sources. So these are repositories, so by itself, metadata aggregator. So this harvesting is hierarchical. And so here one example is shown here for this hierarchical is Chesta, which as well, again, harvest from other repositories like this here as exemplary from the social data network. And so, and especially in particular, we harvest, as Mark already mentioned, from the B2Share, share, and the data repository service of EUDAT. All the meta, and here is a strong collaboration with a strong connection to the B2Share service. And yes, and harvesting and the mapping is implemented in a sustainable way, and in that we can incremental and always up to date and synchronized with the data sources we harvested. So, and this at the end allows users to have really elaborated search possibility to search over a wide spread of data resources coming from cross-domain fields. Okay, and then the next step on the next level. So this is the engagement here, the involvement in the FAIRCORE4EOSC, that then OpenAIRE harvests as well from B2Find, but again, OpenAIRE harvests from hundreds of data sources. So, but in the FAIRCORE4EOSC project we showed here, demonstrate here how this works for B2Find. And then finally, after clean up OpenAIRE and deduplication, all the harvested metadata records and of data sources end up in the EOC data catalog, and so and can then searched via the research discovery graph at the end. Okay. So just so I will now address some things about provenance. So it's very important that you provide provenance metadata on the data set. So it looks here in B2Find like this, that of course the data sets are grouped under the umbrella of the repositories and communities. Here again, an example of a Chester data set. And B2Find not only offers the link to the source itself, but as well a link to the originally harvested metadata record. Here in this case, it's the OAI request for the GET record requests. And we try to provide as much as possible provenance metadata. So for the creator of the data set and the main contact, publication information, publisher, publication year, of course, the licenses and the rights to open the data set and use the data is important. And when it's available, we provide as well, for example, information about the instrument. I will show this later on. Here, very short, I will show how we expose the metadata in XML format, so to OpenAIRE, that they can have all the information about the hierarchical provenance of the repositories. So here's the example that EUDAT first harvests from Chester, but Chester again harvests from others here, for example, from the social data network community or repository. And what is important, as always, that you have good identifiers here. And here we use preferably that the repositories have identified within or registered in the RE3 data, the central registry for repositories, as shown here. So I go ahead. So, and then on the next step, so as said, research the OpenAIRE harvests then, and they as well display then from their perspective a two-level provenance chain. So here is shown that it's the data set was originally hosted at Chester, but if you click here on the Chester, then you see that as data sources as well. B2Find is listed, so because OpenAir harvests directly from B2Find. Okay, I think I have to go ahead, to not running out of time. As I said, it's very important that you have good references and have good persistent identifiers for all the objects and the entities. So as shown here, of course, we preferred for the whole data sets that is the best practice. It's referenced by or a digital object identifier is assigned, but as well, if there's a URL or a quite persistent URL or persistent identifier is as well fine. And then here 3 examples, all the entities and the facets and the fields should be as far as possible assigned by identifiers, so persons like creator or funders, best with the org ID, and as shown already a little bit, so the repositories, so in this repositories chain, so we prefer that there is an identifier or that is all repositories are registered in RISRI data. And I show another example here. We have as well instruments here for instruments in B2Find as far they are provided, and here they then can registered by a use service B2Inst. So I show this here with this example. So you have here data set which has in this provenance metadata part as well this instrument field, and you can see here that in this case a lot of instruments are listed here. And if you click off one of these links here, link icons here, the landing page of the B2Inst service, and quite new EUDAT service, is opened. And here you get more information and metadata about this instrument, in this case an astro telescope, I don't know, from the...
Please wrap up, Heinrich, because we need to move on.
Okay, good. I go ahead. So I will skip this more or less. So, but as I said, in the next step, we want to use graph information from the PIT graph to involve this in B2Find, but we not really started with this yet. And as I said, then we will use the metadata schema and crosswalk registry for the operational ingestion workflow and the mapping workflow in B2Find to handle better the crosswalk from community metadata schema and the mapping to the EUDAT core metadata schema. Okay, sorry to be over time. And
okay.
here you can find some links for information. Okay,
thank you, Heinrich. I'll pass the floor straight away to Harry. To talk about B2 share. You can share the screen.
Let's see if I manage to share. So,
yep, perfect. We can see it.
Oh, sorry, I have to stop and switch my screens. Sorry. Well, it is what it is. I'll try to present it like this. So, hi, thanks for the previous presenters. I'm Harri Hirvonsalo from CSC, IT Center for Science, and I'm here to discuss about B2C enhancements, which FAIRCORE4EOSC components. Just a quick reminder from the whole EUDAT service suite. We're dealing here with the B2Share service on this data access and sharing level. A short summary: B2Share is a dataset repository. It allows storing, publishing, and sharing research data in a fair way. For the context of this presentation or this FAIRCORE4EOSC, it is important to note that B2Share supports describing datasets using the EUDAT extended metadata schema, which is common for all B2Share records. And in addition, metadata records can be described using community-specific metadata elements in addition to this EUDAT extended metadata schema. In FAIRCORE4EOSC, our goal is to, well, make it more easier to work on metadata schemas, management of metadata schemas in collaboration with the communities. And to our, let's say, best view, this goal is achieved by utilizing MSCR, DTR, metadata schema, and crosswalk registry and data type registry in management of these B2Share communities. This slide tries to summarize a very high level interaction between the services. We basically have the EUDAT extended metadata schema described in DTR, and then a community metadata schema in DTR. By utilizing a crosswalk in MSCR, we will provide we will map these community metadata schema elements to EUDAT extended, which will become these common metadata schema elements on the right side of the picture. And those elements that don't map to EUDAT extended will become, let's say, candidates for community-specific metadata elements. In together, this is the, let's say, first draft of a community definition for B2Share. It's not much to say. I could discuss more, but let's save time and move to the next slide. In short, use cases that we see in this project for B2Share is to enhance the community creation utilizing MSCR and DTR, then enhance the community updates in B2Share by MSCR and DTR. Basically, we will get notifications and data about community schema updates through these services. As a third use case, we want to test enabling metadata export from a B2Share record according to some community-specific metadata schema. The, let's say, benefits for the first two use cases are quite clear. We see that the benefit is to ease the management of communities, and for both B2Share service administrators and well, community personals that deal with metadata management in this B2Share context. We also feel that this streamlining will enable more communities on a B2Share instance, which again enables more communities to utilize these, let's say, more than just a generic set of metadata elements, and to actually utilize these community-specific metadata elements, which hopefully will bring value to the community. think in order for the panel discussion to start the panel discussion, I will just end here.
Okay. Thank you, Harri. Thank you for keeping it brief as well. So if all the panelists could turn their cameras on. First of all, let's just try and answer some of the questions that have been put in the Q&A and in the chat. So I think the ones in the Q&A have been answered directly, but the ones in the chat we were unable to. So someone asked, have you made any assessment on the fairness of your data once you make them discoverable using the current tools like FAIREVA or F-UGI, etc., or another tool that has been developed in the context of fairness?
I can say something about B2SHARE and the Fuji tool. We are familiar with the Fuji tool from the, let's say, previous projects that we have taken part in, and yes, we see it as a useful tool for assessments of the fairness. But so far, within this project, it has been, let's say, left outside. But definitely there are plans to evaluate and see how good job Fuji does.
Okay, great. And there was another question in the chat, which was why the SPA-QL protocols for harvesting?
I can just also comment further on this.
Okay, sorry.
For example, if you look at the compliance assessment toolkit, which is also a FAIRCORE4EOSC component, there you can implement different kind of compliance criteria. At the moment, we are developing this for the EOSPD, the PID policy, but you can also implement FAIR policies to develop criteria on assessing FAIR policies.
That's great. And so quickly, the other question that was in the chat was why the SPA-QL protocols for harvesting are not ready yet for B2Find.
For B2Find, yeah, I can comment on this. So the short answer is because in B2Find we had not enough resources and not the possibility. We had some tests to as well collect via SPA-QL, but we focus here as well OpenAIRE does on open OIPMH harvesting. But as I said, now we have another possibility. Now we start with this, that we get via SPA-QL or get the graph information from the PID graph. So they collect all this information. So actually we had this on the agenda for B2Find, but you know, we have not enough resources here in B2Find. So, but for sure, we should go in this direction to collect as well information via SPA-QL. Yeah.
Okay, so I think I'll just ask one panel question. If people want to remain on for 5 minutes, I had a few here, but I'd like to ask the question: how do EUDAT, both EUDAT and FAIRCORE4EOSC, incorporate user feedback from the research community to continuously adapt and improve their services?
I can answer this from EUDAT point of view. We have regular interactions also with users in different fora, so that we collect this kind of information. We do also assessment of our services within our community and also within our members to collect as much user feedback how we want to evolve our services. We have also a user board with a number of members, which also providing feedback to us.
Thank you. In the case of FAIRCORE4EOSC?
Tommi, are you able to answer this?
Sorry, I missed the question.
So the question was, how do EUDAT and FAIRCORE4EOSC incorporate user feedback from the research community to continuously adapt and improve their services?
Well, we have in the proposal stage engaged with specific communities who are in the project and have the resources to really kind of adopt the components. We have the case studies, which I mentioned, which adopt several of the components. And then we have also so-called demonstrators, where they really just kind of try out a single component in a specific context. So those are the user engagements that we can actually directly resource for using the project resources. And then we have open consultations of different kinds. It a little bit depends on the component that you're discussing, because they're all different. We have 9 unique individual different components, and their engagement approaches vary. But as I go around and talk about these things, we constantly get approached that, hey, I would really like to try this one out, and I would like to try that one out, and I would actually like to adopt this. Can I do it yesterday? So then we have written, for example, letters of intent or MOUs with specific organizations who actually want to adopt this yesterday. And you see immediate value added. So then we engage more intensively with such organizations and kind of support their adoption of the component as far as our resources allow. But then they, of course, do the adoption on their own resources. And then we also do have this kind of in May, we will have a physical session in Vienna where we invite kind of potential interested users to come out and try the components and get actually concrete support on how to adopt them. And in addition, I sound like a telephone marketer now, but not only, but also the sister project Fair Impact is having an open call for kind of supporting the adoption of fair practices, which I think the one that we're looking at will close in September next year, which could actually even pay for a small amount of working time for the adoption of these components, should the selected person be lucky, or the organization. So then that even further supports the engagement. So there is the interest side, and then the capacity to actually use time to work with those. So we have tried to keep the palette of engagement large, where our focus is really on the core component development.
Okay, I'm just going to ask another question. If people need to go, they can go and catch this when we post the recording, publish the recording. So for these enhanced EUDAT services, which I know are being enhanced at the moment, but obviously at some point there will be these EUDAT services will be enhanced and published. Will there be educational or training programs to help researchers and institutions better use these services, help explain to them the benefits? Is this foreseen, or?
I can further comment if I know Harri is not commenting. Yes, but that is also done through the projects. Because there we have also the actual engagement with the communities. We also, part of our project, we're also developing documentation and training material so that we are able to train and provide this kind of information. But also there are different ways at different workshops and conferences where we make more interaction with communities. But also, for example, we have the EUDAT conference where we also provide more detailed information of what the services are, but also how these services are can be used, or how communities can take up those services. So there are different ways, and we try to be very active within our communities to promote the services, but also the capabilities which are further being developed within FAIRCORE4EOSC or being extended on our services.
Maybe I can add on that we had the summer schools for EUDAT. So this summer, and I think this was as well very successful to bring the EUDAT services to the researchers and communities.
So yeah, so there's the summer school 1 year and the conference the next year. So right, so every 2 years they happen alternating.
Yes.
So that's a way to get and more knowledge on EUDAT and EUDAT services.
Yes.
All right.
This year we have the EUDAT conference, and next year the 2024 we have the EUDAT conference, and in 2025 we have again a summer school planned.
Great. All right, I think I'm going to close the webinar here. I thank everyone who's still here for attending, for taking part. I want to really thank my speakers for their contributions and the insights that they gave us. And make sure to follow FAIRCORE4EOSC on social media to follow with the projects, how it's coming along and for updates, and make sure to follow EUDAT as well. And you can already start adopting EUDAT services in your research. Thank you very much and have a good day. Bye, everyone.
Thank you.
Thank you. Bye-bye.